Hello and welcome back to Differential Equations, section 7.3 on inverse transforms and partial fraction decomposition. Now, we learned last class in 7.2, right, that we can transform our differential equation into algebraic equation using Laplace transforms. Then we can solve algebraic equation, and then we have to use the inverse Laplace transform to go back to original domain, which we call time domain. And in order to do the inverse transform, we need to know a couple of tricks. Now, the way to do inverse transform can be basic, which is the chart, which you just read, right? Because the answer ended up being just like e to the 3x, right? And you just read that in a chart and you're done. So it could be basic, or it could be partial fractions, or it could be some special witchcraft, right? And when I say witchcraft, you'll know exactly what I mean when we get there, right? So those are the ideas. Now, basic ones, looking at the chart, right, literally means you just take the inverse Laplace of, let's say, f of s, and you get your f of t because it is in the chart. The table, right? Table. That's on the cover of your textbook. So if you have that f of s, let's say f of s, is equal to, let's go with, I don't know, k over s squared minus k squared, right? The chart would say that the inverse Laplace of k over s squared minus k squared is, right, this is a minus, so it's hyperbolic. So it's sine hyperbolic kt. And the way you would use it is, let's say you have f of s is equal to 4 over s squared minus 9. Okay, well, this 9 is actually 3 squared, which means that I need a 3 over here. Let's make all of this stuff red. So I have inverse Laplace of 4 over s squared minus 9. So this is 3 squared, which means I need a 3 on top because I need these k's to match. And this one kind of governs what you must have on top, because you can't really change that 9 because there is a subtraction. And right, the 4 you can massage any way you want up there, but the 9 you can't. So because that's 3 squared, you have to have a 3, which means you have to have 1 over 3 in front to balance the 3 you put out of nowhere on top. And now, this whole thing, these are supposed to be those curly brackets. It's just, there we go. So that's now inverse Laplace of 4 over 3, 3 over s squared minus 3 squared, right? And that gives you 4/3 sine hyperbolic of 3t. So that's the way to use the chart. And you can now use the chart for a lot of other cases, right? Another case that it's also a basic case, right, would be if you have, let's say, inverse Laplace of 4 over s minus 3, whatever, right? So this works out to be, you kick 4 in front of the Laplace transform, and you have 1 over s minus 3, So this is 4e to the 3t, because this situation here is 1 over s minus a converts into e to the a t in the chart. So if you have a 3, right, that a is 3, and then minus matches minus, so it's going to be positive a on this side. If it was plus a, right, plus 3, then it would be minus 3t. So those, subtleties of reading the formulas, right, but that should not make major problems. The second part is more interesting, where we have to use partial fractions. And generally, this is the one that you use most of the time, because you have different situations. Let's see over here. Trying to see. So let's go with f of s. I think this is problem 14. F of s is equal to 5s minus 4 divided by s cubed minus s squared minus 2s. Now, we did spend time, right, on during the review on Tuesday how to do this. But we know we are supposed to factor in denominator, and we are supposed to factor as far as we can possibly do it. In this case, it's going to be this. Now that's basic algebra, right? When you factor all of these terms down to the linear. Now, you're not always going to be able to go all the way to the linear, which is why we have those quadratics around. Now, your partial fraction decomposition, I was about to say partial differential equations. Partial fraction decomposition is a over s, because that's linear, plus b over s minus 2, that's linear, plus c over s plus 1, also linear, needs to be equal to 5s minus 4 divided by s minus 2, s plus 1. Now your job is to multiply by what's missing in each of these terms. Now we see that when it's s, we have this polynomial here. So the top one will be multiplied by s squared minus s minus 2. Then b, we have s minus 2, so I need s squared plus s. And then when we cross out this one, we have s squared minus 2s. So we multiply each one of these by each term by whatever it's missing from the common denominator. And then we can just drop denominators, right, because they will be the same on both sides. We get as squared minus as minus 2a plus bs squared plus bs plus cs squared minus 2cs equals 5s minus 4. And now we collect like terms. So a plus b plus c times s squared plus, and now all the s terms, that's minus a plus b minus 2c times s. And then we have constants, minus 2a only, equals to 5s minus 4. So a plus b plus c is equal to 0, because there is no s squared on the right hand side. Then we have negative a plus b minus 2c equals to 5. That's the coefficient of s. And finally, we have negative 2a equals negative 4, from where a is 2. Now that's really helping because we have b plus c equals negative 2. And b minus 2c is 7 when you plug a into both equations. And now when you subtract these equations, b minus b is 0, c plus 2c is 3c, equals negative 9, c equals negative 3. And if c is negative 3, b better be 1, so they can make negative 2 together. And that gives us our a, b, and c. Now that goes in here. So I'm going to copy this. You can just write it again. Oh, come on. There we go. I'm just going to erase all of these orange thingies we don't need anymore. There we go. And plug in, and erase a, b, and c, and plug in the values. So b is 1, that's good. A is 2, and c is negative 9, so I'm changing that to a minus, put the 9 over there. Good. So, and this is my f of s.
C is negative 3.
Oh, thank you. Yes, yes, yes. C is negative 3. I was just testing everyone, and you just passed this test. Very good. Now our job is to do the inverse Laplace, because f of t is the inverse Laplace of f of s, which means we have to do inverse Laplace of 2 over s plus 1 over s minus 2 minus 3 over s plus 1. And that is going to be, and now all of these are basic ones from the chart in front of your book. So maybe I should write them over here. 1 over s goes into just number 1, which means that this thingy is 2, because it's 2. Let's write it 2 times 1. Plus, and we said that 1 over s minus a is going to go into e to the at, right? So I have a to be 2, so this one is like 1 times e to the 2t, minus 3 times e to the negative 1 times t. I just wanted to make sure that you see that this is s minus minus 1, so that we can get that negative 1 in front of t. So now when you just take care of all this nonsense of times 1, you get your answer. So that's the Laplace transform using partial fraction decomposition, right? We go through this and we factor everything we can, and we go from there. And now we can practice some more of these. Now remember, I also have that third one, but that's actually in the next section, the special stuff. Those are all the formulas that can be used backwards from our 7.4, which is in the next section. So the inverse transform is actually given over 3 sections. There is only one way, right, to go forward. You use the tables to transform a differential equation, right, using Laplace transform into algebraic equation. There's only one way to do that. right? You use your chart, and if something you see is not in a chart, well, good luck, do that integral for Laplace transform with integration by parts. But for inverse Laplace, you have all of these things that are listed, and again, these special cases will be covered in 7.4. Maybe I should just put here 7.4. Well, and 7.5 and 7.6. I mean, there's more of them, right, coming up. But yeah, we're not done with inverse when we're done with this section. Now let's take a look at another full problem, right, with trying to calculate everything. So we have x double prime minus 4x equals to 3t with x of 0 equaling x prime of 0 equaling 0. All right, this is our problem, and we all know we can solve this with chapter 3. This problem done with undetermined coefficients is on your exam in like 4 days. So if you are to use chapter 3 here, that's your exam that it's coming up on, right? Because you have to have this. Your midterm did not have this side, it was 0. But your exam coming up will have this, so you have to use undetermined coefficients or variational parameters. Now, that's an exam too, or a midterm too, whatever you want to call it. Now your final will have this problem again, but it will say solve it by chapter 3, solve it by chapter 7, solve it by chapter 8. Meaning, same problem, right, repeated, and you better get the same answer in all of them because it's the same problem, right? That should be common sense. But when you see this problem, you say, okay, I can solve it by undetermined coefficients, and that's, let's say, question 5. And then question 6 says, same problem, solve it by Laplace. And then question 7 or whatever it is, solve it by power series. So all of the methods that we learned, right, done on the problem. And then you might have another problem, right, for chapter 1, that it's repeated in 2 different settings and so on. But the trick is that you can solve this in multiple ways where people generally use Laplace because it is like the most mainstream, and you use a table and you're done quickly. If the software obviously can solve it. And then the power series is really the most powerful and crazy way to do it. But right, you need to be boss. We'll see about that. Anyway, what do we have? We have a second derivative here, right? And we need to do the transform for the second derivative. Now, second derivative transform is s squared f of s minus s f of 0 minus f prime of 0. And then we don't have the first derivative, and then we have minus 4f of s equals, right? And now I need to transform 3t, which will be 3 over s squared. So maybe I should color code this again. We have our x double prime, which is all this mess. Then we have this puppy right here. And obviously we have this side. So what we see from here is that the Laplace transform of x is f of s. Now you can just put also capital X for it, but you know, once you have systems, you would use that. Like right now, who cares? Okay, so we have all of this, and both of these will go to 0 because of initial conditions. Oh, maybe it's bad to use blue because blue is now this term. What can I use? How about we use this, whatever the hell this color is? Purple, I guess? Someone is going to say, oh no, it's magenta, whatever. Now, if you see what's left, we can factor out f of s and have s squared minus 4 equals to 3 over s squared, which is like, that is nice. That factors and all that, right? So fs is equal to 3 over s squared minus 4, which factors into s squared, and then s minus 2, s plus 2. And there's your partial fraction decomposition again, except now you have 4 of them, right? So it's more annoying. You have a over s plus b over s squared plus c over s minus 2 plus d over s plus 2 equals to 3 over s squared s squared s minus 2 s plus 2. There we go. Now, some students trip on this. Make sure you don't trip on that, okay? It's a repeated linear term. I know you see s squared, but it's also a linear repeated, which is s minus 0 times s minus 0, which is s minus 0 squared, which is s squared. That s minus 0 is s minus a family for our x minus c family, right, which is linear in your setup for partial fraction decomposition. So please make sure that you are not making that mistake. That's Calc 2 facepalm if you make a mistake on that setup. It has nothing to do with you not knowing differential equations. It's just you not knowing fundamental Calc 2 stuff. So be careful about those things. All right, now is the time to multiply again what's missing into each one of these. So in the first case, it's s cubed minus 4s. In the second one is just s squared minus 4. In a third is s squared and then plus 2, so x cubed plus 2s squared. And when this one is saying that's s cubed minus 2s squared, s cubed minus 2s squared. Okay. Now this is elementary algebra, what we just did, or whatever. Find common denominator on rational expressions. Now again, denominators will drop because they will be the same on left and right side. You can multiply through by whatever the denominator is. They will both cancel completely. And we are looking into as cubed minus 4as plus bs squared minus 4b plus cs cubed plus 2cs squared plus ds cubed minus 2ds squared equals to 3. So factor out cubes, squares, singles. So for cubes, I have a plus c plus d for s cubed. Plus, now squares, we have a b plus 2c minus 2d s squared. Plus linears, I have, well, I just have one linear, minus 4as. Okay, minus 4as and minus 4b. Well, that's easy. That's really easy. A plus c plus d equals to 0. B plus 2c minus 2d equals to 0. And negative 4a equals to 0. Guys, this is for s cubed, this is for s squared, this is for s. And as you can see, when you have a 3, you don't have any s cubed, s squared, right? So they're all zeros. And the only one that you have is negative 4b is equal to 3. So from here, you know that your a is 0. And from here, you know that your b is negative 3/4. Negative 3/4. So c is equal to negative d because a is 0 in the top equation. And on the bottom equation, we have a b, which is negative 3/4. So we have 2c minus 2d is equal to positive 3/4, right, when it goes to the other side. And then we are going to plug in, let's do d is negative c, that's better. D is negative c. You plug that in, then you get your 4c is equal to, right, when you plug this in here, you get positive 2c, so that's a 4c equals 3/4, and c is 3/16, which immediately means that d is negative 3/16. A, B, C, D, there they are. Okay, then you go back and copy your setup. And just plug in the numbers. So, no. Sometimes you can just laugh. Come on, change the color. Thank you. Get rid of all of the extra writing. Okay. So D is, now, if you learn your lesson quickly, you know what to do with these fractions. Instead of putting them on top, put 1 everywhere on top and put the fractions in front. So your D fraction is negative 3/16. Your C fraction is positive 3/16. Your B is negative 3/4, and your A is gone. So there you go. Because if you do this, right, then you have your answers immediately. So this is your f of s in the end, that thing. And to find your f of t, you need to do the inverse Laplace of f of s, which means inverse Laplace of this mess. Negative 3/4, 1/s squared, plus 3/16, 1/s minus 2, minus 3/16 of 1/s plus 2. And when you now apply the chart from your the table, right, for the inverse Laplace, we said the 1/s squared is just t. So that's negative 3/4 t plus 3/16. And now this is e to the positive 2t minus 3/16 of e to the negative 2t. And you could call it a day and move along. But we can flex a little bit on this answer, right? It's differential equations, and reduce amount of computations. Now that's obviously important for code, right? Because you heard it many times, optimize the code, meaning just simplify your algebra to the point where computer has less operations to grind through, and on obviously 10,000 operations, if you're able to cut 5 algebraic operations because you simplified your answer, in that case your computer is 5 times faster because it has to do 5 times less work. I mean, your software is 5 times faster. That's technically what happens when they update drivers and patch video games and software and update the software. They are making these simplifications in a code, make computer less, less code, less computations, and they also, right, algebraically simplify answers. Now, what can we do? Well, we can fix this, and we can really fix that one, because you have the structure of the hyperbolic function. If you studied at all, right, your Calc 2, you know that sine hyperbolic 2t would be e to the 2t minus e to the minus 2t over 2. Well, this means factor out 3 over 8, and the rest will be your sine hyperbolic. Now that reduces insane amount of calculations, right? Instead of running all of these calculations, you can just run calculation for sine hyperbolic, and that simplifies a lot. Now we'll count the difference once we're done. So this is going to be f of t is equal to negative 3 over 4 plus 3 over 8, and then you have your sine hyperbolic of 2t. Now this answer is way better than the top answer, because, right, you don't have too many calculations. That is 1, 2, and then 3, 4, 5, 6, 7, 8, 9. 9 calculations in this one, right? Probably 9 calculations in like the first two only. 1, 2, 3, 4, 5, 6, 7, 8. Yep, 9 just here. So you see that you at minimum doubled the speed of your application here, if the only thing the computer needs to do is to compute the formula, this answer, right? So it's important to simplify. I mean, obviously you will know that once you start working in the real world rather than having the fake classroom here. But the thing is that, anytime you can simplify, you should simplify.
Are you also dropping the t for the negative 3/4?
Oh, that's a mistake. That just disappeared. That was my lunch, okay? That was my lunch break right there. It's almost 12, so time for lunch, and I ate the tea. There we go. Very good. So this is our solution. And again, you have to be able to solve this problem by undetermined coefficients, variational parameters. You just must be able to do it. And obviously, your answers have to come out to be exactly the same what you see. And we are going to solve the same problem using a power series. And you are going to get the power series answer to the same problem in chapter 8. So you will have 3 ways, right, to solve this problem. The rest of the problems, as I'm looking at 27 through 38, they're just more annoying situations of the same, right? They push it into a 4th derivative and technically tell you good luck, right? Which, again, is just messy to compute because you have to go with the 4th derivative transform. but we did have the transform for any derivative in a previous section, so you should not be worried about it. Somewhere over here, there we go. That's the first and the second one. And this one over here is the one that would give you the fourth. So clearly, if I should use that language, if this is the fourth derivative, then that's the 4. And then you would have a 3, a 2, a 1, right? And then also f of 0. So it will just trickle down, right? And it's not impossible. I mean, it just takes 2 seconds to figure out in the formula what goes where. You can do the 7th degree if you want to. It's going to take you an hour, but that you can. Just think of partial fraction decomposition coming up, right, for the problem like that. These problems, again, very useful in solving, and they're primarily used in solving mechanical vibration problems and electrical circuits with Kirchhoff laws and all of that stuff. Guys, you are going to see this in your 4-year 300, 400 level courses. Not math courses, but your special courses, right, in mechanical engineering and electrical engineering. You are going to see these calculations. And most likely it will be done through Laplace. And it's not Laplace, then it's power series. No one is going to sit through undetermined coefficients. I don't believe that anyone even knows past the exam undetermined coefficients and variational parameters, the formula you have to memorize. Like, come on, give me a break. Everyone is doing Laplace and power series. Right? If you can code it, right, and if you can't do that, you just do the code, right, for approximation, because that's also good enough in the era of what we're doing here. So that takes care of 7.3. I want to go into the review after the short break, and then I guess next class will take care of 7.4, and as far as we can go into 7.5 for the next class. Next week we have power series, and following Monday would be the course review, going into the final on Wednesday. We only have 2 weeks left, guys. Technically, 2 weeks and Wednesday, next week. So 16 days from today is your final. It's very, very close. So I hope you will be practicing this stuff every day. All right, let's take a short